Unit 7, Section 5, inverse trig ratios. Inverse means you've replaced the y with the x. Okay? You've replaced the input with the output. So, and it also means reverse, right? So the inverse of plus is minus, the inverse of multiply is divide, the inverse of squared is square root. So we need to know the inverses of all the trig functions. So don't forget, so, ka, toa, sine, cosine, tangent. If you know the sine, cosine, or tangent ratio of an angle, so you know the number on top divided by the number on bottom, you can use the inverse ratio, sine to the -1, cosine to the -1, tan to the -1, or arc sine, arc cosine, arc tangent. Okay, those are also known as ARC sine, arc sine, like that. Okay. You can use that to find the degree. So if you know all of the sides but not the angle, you can do the arc or the inverse sine, cosine, or tangent in order to find it. So let's look and see. Don't forget, make sure your calculator is in degree mode. If you're in radians, you will not have the right answer. All right, so here's our angle in question. We've got a 15, which is opposite, and we've got the 24, which is opposite the 90, so that's going to be the hypotenuse. OH is SOHCAHTOA. So we want sine of x to equal 15 over 24. Now what we do is we do the same thing to both sides. We sine to the -1, and that's going to cancel out the sine part. So x equals sine to the -1 of 15 over 24. So instead of plugging the degree into the sine part, we're going to plug the ratio into the negative, the inverse, or sine -1, or the arc sine. And that should give us what degree measure we are approximately. So I'm going to go over to my funcs. I'm going to do sine to the -1, and I'm going to say 15 divided by 24. And it tells me that I'm approximately 38.7 degrees is what that angle was. Now, if you are on one of those different calculators, the fun thing about most of these is that the sine button, which is 2 up from the number 7, has the sine of the -1 on it. The cosine right next to it has cosine of the -1. Tan right on it, tan of the -1. Most of the opposites or inverses are next to each other. If you look at the x squared, it's got a square root on it. If you look at the log, it's got 10 to the x. If you look at ln, or the natural log, it's got e to the x. Divide and multiply right beside each other. Minus and plus right beside each other. They're all opposites. I'm going to keep using Desmos though. Okay, we're probably going to need it a bit, so I'm just going to do a little splitsy screen here. All right, so we got this guy here. This one's the hypotenuse. This one's adjacent. So that's I can skip a bit and just say that x is going to equal the I don't even know what that was. The cosine of the -1 of, and then my fraction, opposite or adjacent over hypotenuse, so 8 over 11. And then I just type it in the calculator. So I'm going to do our cosine of 8 divided by 11, and we get 43.3 degrees. Okay, you stick that trigonometric ratio into that arc cosine, or that inversed cosine, and it will give you your answer. Okay, so let's keep going. Let's practice up a bit. Here we go. We've got what would be opposite. This is the hypotenuse, so that makes this one adjacent. So we got opposite and adjacent. That's tangent, so x is going to equal the tangent to the -1, the inverse tangent, the arc tangent of opposite over adjacent, 20 divided by 37. Okay, so we're going to go funcs arctan of 20 divided by 37, and we get 28.4. X is approximately 28.4 degrees. There we go. Go ahead and give it a pause and see what you can do on 4, 5, and 6. Here we go. We've got next to, which is the adjacent. This is the opposite. That's the hypotenuse. So we've got adjacent and hypotenuse. That's cosine again. So the x equals cosine of the negative 1 of the adjacent 18 over 23. Okay, so we got cosine 18 divided by 23. That would be 38.5. That's an 8, I promise, degrees. This one here, straight over. That's opposite. That's adjacent. That's hypotenuse. We got opposite and hypotenuse, so x equals sine to the negative 1 of, let's get that opposite, 40 over adjacent, 41. Excuse me. Bunks, sine 40 divided by 41. So x is approximately 77.3 degrees. Very nice. And over here is opposite. This would be adjacent. This is the hypotenuse. We got TOA, so x equals the tangent to the negative 1 of opposite 7 over adjacent 5. So x is approximately 10. What do we got on top? 7 divided by 5 is 54.5 degrees. That's how it goes. Find the value of x, round to the nearest tenth. It's more of the same problems, okay? Well, let's just review. So now we're going back the other direction, right? We have the angle, so we have the thing that we will sine, cosine, or tangent. We just need the other side. So we go over here. This is opposite. That would make this one adjacent, while this one is the hypotenuse. So we have OA, tan, TOA. So the tangent of 39 degrees is equal to opposite 11 over x. So we're going to give it the old ratio switch and make it 11 over the tangent of 39. So 11 divided by tangent of 39. So x is approximately 13.6, whatever units that they're measuring. Go ahead and give it a pause, and let's see if you can figure out the last three. Come back, let's see how you do. Right, here we go. We got this one. Right next to it is adjacent. That makes this opposite. That makes this the hypotenuse. We have adjacent and hypotenuse, ka. So that's cosine of 46 is going to equal adjacent, which is x, over the hypotenuse, which is 28. We're going to multiply by 28 both sides. So x is approximately 28 times the cosine of 46 is 19.5. So how far we get there. Let's check the next one. We've got opposite. We've got adjacent. This one's the height. We got OA. So the tangent of 51 is equal to opposite, which is 8 over x. Give it the old swap. And let's see, was it 8 divided by the tangent of 51 is 6.5 approximately. Let's hit that last one. We got opposite. This is a hypotenuse. That makes that one adjacent. So OH sine 24 equals opposite x over 31. So multiply by 31 both sides. X is approximately 31 times the sine of 24. So we get 12.6 about. And that's how it goes. That's trig, forwards and backwards. You got sines and inverse sines, cosines, inverse cosines, tangents, inverse cotangents, or arc sine, arc cosine, arc tangent. If you've got two sides, you can find the degrees with the inverses. If you've got an angle and a degree, if you got an angle and degree, you can find the other side with the inverses. If you've got both angles or both sides, you can find the degree measure. So there you go. Good to go.